afternoon, sir.
Okay. Yeah, I want to wish you once again for the recording. Good afternoon, guys. So welcome back to the highway engineering. I encourage you guys to be quite active enough and let us be little interesting because the lockdown starts. We don't want to go anywhere. We need not to go anywhere. Just please focus on the topics. What I tell you. If you guys any, if you guys have any doubts regarding the previous classes, please ask me. I just want to give you a brief introduction what we are discussing so far. So the last classes or in the previous classes, what I have discussed or what I have told is number one, improvements of highway. Yeah, improvements of highway. Okay, in that we have discussed about the JCAR recommendations and road plans. Okay, and road plans and road patterns. That's all. So this is about the first unit, and the second unit we are discussing is the geometric design. Okay, geometric design of highway. Okay, so in this geometric design, what we'll do is we'll be discussing about the road and its dimensions and its property and all the visible features. Okay, uh, regarding its length and regarding its cross section and all types of features. Okay, so I have given you the brief description and introduction about what are all the cross section elements of a highway. So the cross section element represents the width and the cross slope. Okay, the cross slope of a highway. Similarly, we have also discussed about the types of gradients. Yeah, and the problematic wise we have talked about number one is cross section elements. These are the things you need to know as what are the elements are there in a highway. And number two is yeah, number two is side distances. Yes or no, guys? Side distances. So in side distances we have dealt about stopping side distance and headlight side distance and intermediate side distance, which is 2 times of SSD. And finally is the recent classes we have dealt about the OSD. So all these topics are quite important in the highway design. And today we are going to discuss about the new topic called not the side distances, not the side distances, but we are going to talk about we are going to talk about curves. Okay. So you guys have seen and you might have seen what are the types of curves along a highway. Okay. So basically in a highway, we find or we face the two types of, we see basically two types of curves. That is number one is a horizontal curve and the second is a vertical curve. Okay. So horizontal curve in the sense for a plan. So this is called horizontal curve. Okay. In the sense the vehicles move in this direction. So these kind of horizontal curves having a minimum radius are called the horizontal curves. And when we talk about the profile, okay, when we talk about the profile, these are called the vertical curves. So here we can draw the picture because in the profile we will be able to see the vehicle. So here these are called the vertical curves and these are called the horizontal curves. So you got the brief idea about that. And these are called valleys, in the sense valley curves, and this is summit curve. Okay, you don't have to remember these vertical curves right now. Today we are going to discuss about the today we are going to discuss about the one of the important most topic called horizontal curve. Okay, please be attentive. Yeah, in this topic or in this chapter, let us say in this concept, we'll be looking at the design of horizontal curves. So at the horizontal curves, what are all the parameters we need to take care of? Those things we'll see one by one. So in the horizontal curves, we discuss about the three important topics. Number one is called the centrifugal force. What is this, guys? Number one is the centrifugal. Right, this is centrifugal force. Right? And number two is the skidding resistance. And number two is overturning. Okay. Uh, Guys, how many of you heard about what is meant by centrifugal force? Centrifugal force. Okay, no issues. So when we take a curve, okay, when we take a horizontal curve like this, okay, when we take a horizontal curve, when the vehicle is traveling at higher speed, okay, uh, when the vehicle is traveling at higher speed, what happens is its velocity will be tangential. Okay, at this point, the velocity will be in the direction of like this, and here the velocity will be like this. It will be tangential. Okay, it will be tangential like this. But for a flat road, that means for a straight road, its velocity will be tangential likewise. So during the maneuvering of a curve, that means during the traveling of a curve, what happens is its tangential velocity will be facing towards outside of the curve. That means due to this tangential velocity, what happens is there will be an impact called the vehicle will be dragged towards the outside of our outer line of the pavement. That means what happens is the vehicle will be dragging or the vehicle will be dragged towards the outer. So what happens is during the dragging, okay, during the dragging, there can happen two chances. Okay, there can happen two chances. Okay, when the vehicle is being dragged outside. Okay, so this is the mirror. Try to understand. Okay, so okay, when this is a vehicle, okay, and then when the vehicle is dragged at the sideways or when it's dragged outwards, what can happen is that can happen. There are two possible chances. Number one, it can skid at the lateral direction. That means it can skid because we are pulling it outside, right? We are pulling the vehicle outside. And the other thing can happen is and the other thing can happen is what can happen, guys? When the vehicle is pulled towards the outside, what can happen to the vehicle? Yeah, The vehicle can overturn. Yes or no? That means this overturn is also called toppling or topple. So what happens is the vehicle will overturn likewise. Okay. So during a curve, what happens is the vehicle might skid here, or the vehicle can fall outside of the curve because of the centrifugal force. This one. So in this chapter, we are going to design what are the parameters we need to do for skidding to avoid skidding, and what are the parameters we can do to avoid overturning. So basically, we can't do anything just like that. We have some derivations to be followed, and there is a basis where we need to discuss about that. Come on, let's go into it. We'll discuss about the first one. Yeah, first one. Let us discuss about the mm, centrifugal force and overturning. Okay. Now what we'll do is the centrifugal force. I'll give it in a formula, that is the P. P is usually given as W into V square by GR. So that is one of the formula we need to remember. Centrif Centrifugal force is given as capital P is W into V square by GR. That means, yeah. So it can also be written as P by W is equal to V square by G. So that's the thing we need to remember. So this P by W is called centrifugal ratio. So P by W is V square by GR. This is one thing we need to remember. Now we'll do a small derivation regarding this. Okay. Let us assume we are calculating it on a flat surface. So these are the vehicle, and this is the P acting. The total width be B. Okay. Now what happens is the total height be H. Total height in the sense height at where we are going to calculate the centrifugal force. Okay. So the moment caused due to the centrifugal force will be equal to P into H. Okay. This is the moment caused due to the centrifugal force. And we have W here. Okay. And in order to overcome, or in order to counteract the vehicle toppling from the centrifugal force due to the centrifugal force, what we will have the moment to balance or to stabilize the vehicle is W into V by 2. So we need to remember that. So if this is a vehicle, okay, so we are seeing it in the front view. So when the centrifugal force is acting outside, okay, let us say the height be H. Let us say it is the point of center of gravity. So what happens is the moment it is causing is a P into H. So the moment resisting that should be W into B by 2. What is that B by 2 is? It's the width of the vehicle from wheel to wheel. Okay. Now let us equate the moments. Equating P into H with W into B by 2, we get P by W is equal to B by 2H. So this is the important condition number one we need to remember. Okay. So what I am telling is in order to have the vehicle in equilibrium, that means centrifugal force should not drag it outside. Similarly, weight should also hold it to be balanced. So for that, the equilibrium condition should be P like this. P by W is B by 2H. Okay. That means that means here the height of the vehicle should decrease with respect to the width. That means let us assume if a vehicle is having wheels like this. Okay, this is the front view. So this is one condition, and the other thing is the same vehicle with less height. So which vehicle will have more balance? So the base width is the same. This is B, and this is also B, but this is a height, let us say 10, and this is a height 2 meters. Okay, so which vehicle is going to have more stability? Come on, guys. But I'm able to see the video. Anyone having any issues with the video? No, right? I'm able to see my video here. Yeah. So small vehicle is going to have more stability, and the vehicle which is having more height, so it will fall or it will be subjected to centrifugal force very easily. So that is why we have the equation like this. So our base should be more with respect to height in order to counteract the centrifugal ratio. It's also called impact factor also. Mm, no issues. So the first condition, in order to do what we say, for stability, okay, for stability, our vehicle's dimension should be equated to the centrifugal ratio, number one. And when we talk about the skidding action, skidding, okay, skidding and centrifugal force. Okay, say this is a vehicle like this, and we have its vehicle wheels like this. This is a road. So what happening is from the center, its weight is acting, and again towards the centrifugal forces dragging outside of the road. So in order to counteract the centrifugal force, okay, in order to counteract this centrifugal force, what happens is friction develops between the wheels and the road. So here will be subjected to frictional force. That means in wheel 1 will have friction force 1, and the in wheel 2 will be having frictional force 2. Okay, so how we are going to equate it is here the wheel is going to exert Ra. Okay, and this shall be Rb. So how we need to do is frictional force at A wheel. Okay, frictional force at A wheel will be equal to the coefficient of friction into Ra. Similarly, frictional force at B will be frictional force, friction coefficient into RB. So summing up, summation will be having F into RA plus RB. Try to follow me because the derivations in the textbook will be quite different for you to understand. So FA plus FB, okay, will be equal to F into RA plus RB is the total weight acting on this. So that is what we get this one. So let us say FA plus FB will be, let us assume, is a total frictional force. That is the total frictional force acting at the between the wheels and the road. That is F into W. Okay. Now coming back to here, our P is counteracted by our frictional force. So what is a frictional force? F into W. So getting back here again, what happens is P by W. That means getting back this here, P by W will be equal to F. You're understanding? So what I mean to say is, in case one with respect to the dimensions, okay, in order to have the body at stability, our centrifugal ratio should be equal to B by 2H of the vehicle, concept number 1. And to avoid skidding, okay, to avoid skidding, what we need to do is our frictional force is going to counteract this centrifugal force, and when we are equating all those things, we will be getting that centrifugal ratio will be equal to friction. So this is with respect to dimensions, and with respect to the skidding, we have P by W is F. Okay. So from the above two equations, what we can write is B by 2H equal to F is equal to what? P by W. So this is the equilibrium condition we need to remember. Okay. Now, for the in order to counteract or for avoiding overturning, in order to avoid overturning, B by 2H should be greater than P by W. Guys, the dimension or the ratio we are getting to the base towards to height should be greater than the centrifugal force. Similarly, to avoid skidding, what we'll do is the frictional force should be greater than P by W. You're able to understand? So these are the two derivations I have got with this one with the movements, and this equation I have got with respect to equating the forces. So from the both I have drawn the conclusion saying that the dimension and as well as the friction will be equal to the centrifugal ratio. But now comes the picture. But for the safety point of view, what it should happen is the base to the height ratio will be greater than the centrifugal force. Similarly, okay. Similarly, our friction should be greater than the P by W. Now, what about the relation between these two? If B by 2H, if B by 2H is greater than F, so vehicle overturns first. Okay. If friction is greater than B by 2H, I'm sorry, if a B by 2H is greater, the vehicle will skid. Okay, because the body stability is good. If a friction is more and B by 2H is less, so vehicle will overturn. So these are the primary formulas we need to remember. So recalling all those things, our equilibrium equation states that our base to 2 height equal to friction, it should be equal to P by W, where P by W is V square by GR. That's the formula I have given you in advance. Okay. One more 9 minutes. Okay. Now let us draw the or let us now solve the another equation. So I have been stressing the words called overturning, overturning, and skidding. Okay. So during the curves, okay, during the curves. So what we need to do is to avoid overturning and skidding, we will raise this outer edge. This is called outer edge, guys. We will raise the outer edge with respect to the inner edge. So, sir, how are we going to raise the outer edge? So, for example, if our rod is initially like this, okay, that will be raised like this. Okay, so the vehicle will be like this. So the centrifugal force cannot overcome this raising. Okay, and moreover, when we have a vehicle like this, okay, guys, when the centrifugal force is pulling outside, so what happens is the vehicle at the or the wheel at the outer edge will be subjected to the wheel at the outer edge will be subjected to more load. That means we'll be having more F into RB compared to the wheel at the inner edge. Okay, that means in the let us assume or let us say in the preliminary conditions when the road is flat, usually in the curves, okay, in the curves without elevating, what happens is the vehicle will be subjected to more load at the outer edge. That means at here. That means the vehicle will be pulled like this. So more load will be falling at the outer wheel, and this is the load distribution. The wheel will have more load, and the inner wheel will be having less. But if we raise that wheel, okay, but if we raise that edge of the road, or if we raise that road height, what happens is the wheel distribution will happen equally. So some of the load is distributed to the inner wheel also. Similarly, overturning can't happen this way. Yes or no? Because we have raised the edge. 6 minutes. Huh? Okay. Now we'll equate it one by one. Okay. So what are the forces acting at the curved surface or forces acting at a horizontal curve when we raise the edge? Okay. So this is let us assume this is the road edge. That's the road, and this is the cross section. Okay, now so this is a truck here. Yeah, and what happens is the truck's weight will be subjected to downward like this. That is W, and the centrifugal force will be acted straight to the or perpendicular to the weight. This is centrifugal force acting on this. Okay, let us assume that we have raised the edge to an angle theta. Oh goodness, this is theta. Okay, while resolving the forces with respect to the plane, we'll get forces like this. Okay, so these are the forces. So weight is acting normally to the surface, and centrifugal force is acting horizontally to the surface. But now we want to equate the forces with respect to the road surface. That means with respect to road plane here and perpendicular to the road plane here. So here let us assume the angle is again theta here, and we'll get P cos theta here, and P sin theta. This is also theta. We get W cos theta, and W sin theta. Okay, and as I have told you previously, the frictional forces will be acting at the wheel edge. The frictional forces will be acting at between this one, the wheel and the road. Here is the frictional forces. So frictional forces is like taken as a W F is equal to F into the reactions. Okay, our frictional forces are taken as coefficient of friction into the reactions at the wheels. This is one reaction and the other is another reaction. Okay, please try to focus. 2 minutes more. Okay. For stability condition, what we'll do is the pulling force, centrifugal force should be balanced with these kind of forces. So I'll write the equation and we'll close the section and start again. So here, what it says is P cos theta, that is the centrifugal force acting horizontally or normal to the or parallel to the plane. P cos theta will be equal to number one is a W sin theta, and we have the same frictional force acting at the road surface. Number two, weight acting at the normal direction and the frictional forces. So that is will I'm sorry, plus what we'll write is frictional force coefficient into RA plus RB. Okay. Now we have is W sin theta plus F into RA plus RB. That means the vehicles acting normal to the plane will be equal to W cos theta plus P sin theta. Okay. Now getting back to the P terms and the W terms, what we'll have is less than a minute. Okay, guys, so please close the session and rejoin again.